Guys, now we're beginning Unit 7. Finally, we've made it to quadratics. I don't know. For some reason, I always associate algebra with quadratic equations, but it always amazes me that it takes this long to get to them. So all year long, I mean, we've looked at quadratic equations a little bit and different parts of it, but pretty much all year long we've been doing the linear functions or linear equations, and so now we're doing quadratics. So I'm really glad to be here as we're zooming towards the end of the year. So let's get started. So first off, just a quick reminder with linear functions. I don't know if you remember, but with the linear function, it was y equals x, which is why with the linear function, the parent function just created this straight line that went straight up through, because if x was 1, y was 1. If x was 2, y was 2. If x was 3, y was 3. And that's what creates that parent function, which is a straight line that goes straight up through the origin. Okay, now we move on to quadratics. Look at this parent function. And if I write it like, well, that's like an equation. If I wrote it like a function, it would look like this. It means the same exact thing. So what's different? What's different is x is squared. And because x is squared, it creates this parabola shape. Parabola. All right, and you can see it over here to the right, the parabola. And that's because, let me just make up some numbers. -1 times -1 is 1, and 1 times 1 is 1. 2 times 2 is 4. -2 times -2 is 4. So when you're squaring a number, it always ends up positive. So you end up with these U-shaped lines instead of a straight line, like a linear line. Okay, so what do we got here? We have, first off, we have our x-intercepts. And I know with the linear equations, we talk a whole lot about the y-intercept. We talked a little bit about the x-intercept, but we will talk more and more about the x-intercept in this situation only. This was our x and our y-intercept. You can see it right here, and you can see it right here. And just so you know, too, just a quick reminder, we've mentioned this too, that they're also called the roots, the zeros, the solutions. I remember we had some kind of like a benchmark star test or something. And the question was either what are the roots or what are the zeros? I can't remember which it was. It was one of those two. And of all the questions on the entire benchmark test, that was a question that students were asking me. Of course, I couldn't answer it at the time, but it was something like this, where I'm just like, it's just the x-intercept, but I couldn't say it at the time. Okay, axis of symmetry. So if I cut this parabola in half, exact half, to where it's a mirror image on both sides, we call that the axis of symmetry. Okay, so it cuts it in half exactly. All right, and at the very point of that axis, I don't know, where the parabola crosses the axis of symmetry, we call that the vertex. So these are all very important vocabulary words I want you to remember. So that's why I wrote it all down and I talked about it. There you go. Okay, so the vertex. So let's talk about again. It's the point where the graph changes directions. Getting that? Feel free to pause this video at any time. And then there's two important words that you will also have to know, but it's so easy, just don't forget it. So if my parabola, it goes up like a U, then this point, this vertex, is the minimum point. If I end up flipping this parabola upside down, and we'll talk about how you can do that, then this becomes the maximum point. So the vertex is either going to be the minimum point or the maximum point. Okay, concavity It is the direction or the direction the graph faces. When I say graph, I mean the parabola. So this is concave up because it's going up. That is up. I'll go ahead and say concave up. And then, of course, you would know that this is concave down. I mean, this could be a question on a test. It's an easy question, but you have to know the vocabulary. All right, so the parent function, what is it? It's y equals x squared. So I created a table, or I copy pasted a table. And so all the x points are just made up. If you're wondering where they came from, they're just made up points. So using the equation, if x is -3, -3 in parentheses squared is a +9. -2 squared would be a +4. -1 squared would be a +1. 0 squared is still 0. 1 squared, duh. 2 squared, duh. 3 squared, 9. All right, lots of does on there. Now I could graph all these points and you could see how a parent function is graphed, because this original graph was not actually a parent function. So first off, for sure, at 0, 0, you're going to have a point. It's going to start there. This is just the parent function. So if I have a -3, 1, 2, 3, then I'm going to have a +9 right there. And then -2, 1, 2, and then a +4. -1, +1. 1. Now watch these points on the other side. They're all going to mirror. 1, 2, 1, 2. You don't even have to really graph them. 1, 2, 3, 1, 2, 3. They're all going to be mirror images of each other. Okay, so here is my parabola. Bam. And it goes on forever, and it goes out. So it goes out gradually, and at least on the parent function, it goes out. But just so you know, it goes on and on and on and on and on and on forever. So domain is x, range is y. Do you remember that? Domain is x. And so the domain goes on and on and on, where x equals all real numbers, because it goes on and on and on. The vertex on the parent function, and not all parabolas, but on the parent function, is 0, 0. It is the minimum. It is concave up. The range, so the range is not all real numbers. Now I want you to notice the range is starting right here. Remember, range is y. All right, so it's going to equal y, but it's also going to be greater than the y, or I should say greater than 0. So it's going to be equal to or greater than 0. That is what y is. It's not all real numbers like the domain is. The line of symmetry is x equals 0, because this is an equation of this line. This is a line. Remember all the x lines? X is 1, x is 2, x is -1, x is -2. When it goes straight down the middle on the y-axis, x is 0. The solution, remember the x-intercept, is the solution x equals 0. Okay, and I'm going to go ahead and put this in here. There's only one. So what does that mean? So with parabolas, wherever it crosses over the x-axis is a solution. There could be no solutions. It might not cross the x-axis at all. There could be one solution, or there could be two solutions. So I went ahead and just noted that, even though technically we haven't learned it yet. We'll get to it though in a little bit. All right, let's keep going. Almost there. All right, so I'm going to look at this one. This is just a random parabola. You notice that this one right off, it's not concave up. This one's concave down. It's flipped upside down. The vertex is right here, and if I named that ordered pair, it would be -2, 4. it is the maximum because it's concave down. And there again, I'm just going to go ahead and say down because that's what it is. What are the solutions? Okay, it's crossing here and it's crossing here. So I don't have to write the ordered pairs. I can just say x equals -4, x equals 0. Those are my solutions, -4 and 0. The line is symmetry. So let's see what it is. It goes through -2. So it's x equals -2. And then the domain is, remember, the domain on this particular, now I have to add something because I want to follow the key that I have. So we're going to just say that there's dots on the end. You might not, that's, it could be arrows. We don't know for sure, but I'm going to go ahead and put dots on the end so that I can explain this domain. So this domain is not going to be all real numbers because it's not going to go on and on and on forever. So the domain, which is our x's, if you look, it starts here at the -5. It ends here at the +1. So my x, -5 and +1. And it's a dot, so it includes them. So that's how you write it. This is going to be what messes you up, is writing these domains and ranges. So let's be careful with them. The range is the y. So it includes that 4. So y is it more than the 4 or less than the 4? It's less than the 4. So y is less than and equal to the 4. And that, wait. Let me make a correction. I have to make a correction here. Let me erase this. Because I forgot. I already forgot. All right, look. It ends here. It doesn't go on and on forever. So let me correct myself. So I'm going to put the y in the middle. Now, be careful because the lowest point, or the smallest number, it's going to lead with that. So I'm not going to lead with the 4. I'm going to lead with what looks like the -5. And the 4 is going to be on this side. And because they're dots, it's going to include it. Well, I almost made that mistake, and I'm sure I would have had many, many students correcting me. But that's okay. I like it when y'all correct me. It means you're staying on your toes. All right. Good luck. I know you're going to do awesome with this assignment, and I will see you later. Bye-bye.